So I'm recording on this computer. And so welcome to our Cyberops meeting for today is March 14th. Thank you everyone for being here. First off, I want to open up any questions before we get started. We're going to go through a couple chapters here. We're actually into modules 11 and 12 are the main chapters that are due this week, and they're very easy chapters. So we're going to look at 11, 12, and 13. We're going to blow through 11 and 12 fairly quickly because they're not that hard to do. But I want to open up any questions, having any issues with the labs, either locally or on NetLabs. Anybody having any problems with the labs at all? No lab issues? Good. That's what we like to hear. But if you do have them, definitely let me know. So let's just start out here and talk about network communication devices. In this chapter, again, quick survey. The three of you, have you all had CCNA 1?
Yes.
Okay. Yes, Steve, you've had one. Jared's had it. I know Uzma has because Uzma's been in my class. You will notice that many of these videos are straight out of CCNA 1 again. So just like I talked about in the previous chapters up here, looking at the ARP transport protocol, I do think one of the important things here is if a student's not extremely strong in networking, make sure they understand the OSI model and they're understanding the layers that these different devices are working at. It's very important, especially when we start talking about switches, because we want them to understand how layer 2 works so they can continue to understand MAC addresses, ARP requests, ARP replies, and the security implications of attacks on the ARP table of different devices. So here we are looking at routers, looking at layer 3 routing, looking at the internet work here, the LAN, WAN. They need to understand what a LAN and a WAN is. I always take time during this time to talk about PANs, or personal area networks, which are networks that are within on our personal self. A good example I give of that is if you've ever had a Fitbit, or when I was riding, in fact, one of the wild things that happened, I had, when I was hit, I had a GPS on my bike that was connected to my phone, and it was tracking me, and my wife could look at it and know exactly where I was at. And the system, she looked at it before the hospital had called, and it showed that I had been in the same place for like 30 minutes. Well, the week before, it had just locked up and caused a problem, and the same thing had happened, so she didn't think anything about it. But that was a personal area network where it was monitoring what was going on and sending that up to the cloud. They're working on systems now, especially with the military, to do personal area networks that will give us the connectivity and ability that we've seen, like in the movie Aliens, where they're actually watching the heart rate, the perspiration rate, the respiration rate of soldiers. And then they can also track soldiers, which could have a very big help in urban warfare if a soldier was captured and possibly taken by the enemy, and they're trying to move them and keep them secret. There's a way to track them, and it's even, there's been some thought of having something you could ingest and have in your system that would be there for a while, and then obviously it would come out. But those type of personal area networks are really not mentioned that much in this class, but it's neat to talk about because I think it gets students interested. Then I use that kind of to go, well, imagine, for instance, these insulin devices they have now that are Wi-Fi controlled insulin pumps, and they pretty much have proven with those that they can hack them and possibly give one a fatal dose of insulin, which is really, really scary. So again, we're looking at the OSI model here, layer 7 through 1. Remember, layer 1 is somebody give me layer 1. Steve, what's layer 1?
I'm sorry, I was muted. Can you hear me?
Yep. What is layer 1?
Physical.
Physical layer. What is layer 2, Steve?
Data link.
Data link. Okay, Jared, what is layer 3? You're muted, Jared, so just so you know. Layer 3.
Sorry, I actually just came up to a red light.
Oh, that's okay. That's all right.
I'm halfway driving here. So let's see.
Oh, here's a good test then. What's layer 3 of the OSI model?
Network.
Network layer, good. Okay, Uzma, what's layer 4? I want to ask you again, Jared, since you're driving. I'd rather you be safe. I'd rather you be safe than. Usman, do you know what layer 4 is?
Transport,
Transport, Steve, good. Layer 5,
session,
and then layer 6 is
presentation,
Presentation. Layer 7 is
application.
application. So layer 7 to layer 1, I use the mnemonic, all people seem to need data processing. And then from layer 1 to layer 7 is, please do not throw sausage pizza away. Those are the two mnemonics that I use to remember these. This particular diagram is excellent because it shows how on every single hop, the packet has to be taken apart all the way up to layer 3 so that there can be a route table lookup. Now, we do know that with modern routers, we have the Cisco Express forwarding table. So we have the CEF table, which has a forwarding information base. So even though it does take it apart to layer 3, most of these devices now are not doing an actual route table lookup. They're able to do a very quick look into the fib, make a decision, repackage it, put a new header back on it, and send it back out. But it is kind of amazing. Every time I see this and then think about how far away in numbers of hops some of these sites that we go to are, it is amazing how quick the internet actually does work. So here's an activity where they're actually showing matching layer 2 addresses. So what would be the source IP, destination IP, and source and destination MAC address in these particular items. So PC1 is sending data to PC2. All devices are ARP complete, which means ARP has taken place. So there's been ARP requests and ARP replies. And so the MAC address for the destination would actually end up being the MAC address of R1, which is 0C03. The source MAC would be 0A10. Source IP would be 1.10. And destination would be 4.10. And you can check it. And that way it helps them know whether or not they understand the concept of proxy ARP. And that is where the router will supply its MAC address to the ARP request. Because remember, ARP is a broadcast and cannot pass by default across the router. And then here they're going through the entire process of doing route table lookups. Find the longest match in the route table. Among the many different ways it could be in there, there could be connected routes, static routes, dynamic routes. The big thing too is if there's no route in the route table and no default route, it goes in the bit bucket. All right, right here. But if there is a default route and there's no specific route in the route table, it will forward it to the default route next hop, whatever that happens to be. So again, looking at directly connected routes, going through looking at what would be on R1. R1 would have 3 directly connected routes. R2 would have 3 directly connected routes. And then R1 would have 2 remote networks and R2 would have 2 remote networks if it learned about all of the routes in this internetwork. I really like the routing table. I like looking at the routing table. I like knowing about the difference between static and dynamic routing. I am actually teaching CCNP Encore right now. And one of the things we're deep into is OSPF and how OSPF works. And that is always fun. We're getting ready to go into BGP too, which is a really cool topic, neat thing. So hubs, bridges, and switches. One thing I always teach students is a bridge is just a 2-port switch. So that's why you learn with spanning tree about bridges and bridge IDs. And the reason why switches have bridge IDs is because they are just multi-port bridges. That's all a switch is. It's a multi-port bridge. Now, typically, I tell my students hubs are of the devil because they are layer 1 devices that will just repeat anything sent into them. Typically, there are different types of hubs. There are repeater hubs that actually will bring the signal in, strengthen it, and then send it on. There are just dumb hubs. There are different types of hubs. But in the world of security, hubs actually do have their place because we can put them in areas that we want to tap network traffic. And the hub will send everything that comes in one port out all its other ports. So there are actually places for hubs. In the modern world, on modern switches, we can also use a concept called spanning and even remote span, which allows us to mirror a port on a switch to a port that has a some type of port analyzer or a span port on it. So here's different types of switches, multiple different types of fixed configuration switches. I always tell my folks that have networking classrooms, it's a good idea to have many different types of switches in there and show them to their students. These are all fixed. They're also what they're called chassis switches. And those are ones that have line cards you can slide in, which are very neat. And then it goes into a very good and honestly a repeat of what's an introduction to networks and in switching, routing, and wireless essentials, the SWE class. And that is how a switch makes decisions based upon its MAC address table. Remember how whenever a frame comes in, the source MAC of that frame is always placed into the MAC address table as being on that particular port. So when this frame comes in, it takes the source MAC, puts that in, and says that particular machine or that MAC, and I know they're only showing you a portion of the MAC address table or MAC address because it's typically 48 bits, but they're saying that's on port 1. Remember, if a destination MAC address is not in the MAC address table, it will flood it out all, it will flood the frame out all ports except the one that came in on. Because it assumes, because of the way Ethernet works, Ethernet is a multi-access broadcast system. And so it assumes that if it was on this segment already, then that particular host would have responded. So there's no need to send it back out where it was coming in from. But in this case, if it looked and there was no 000D in the MAC address table, it would flood it out all the other ports and add the source MAC to its MAC address table. Now, if it does exist, so let's say that 0A is sending to 000D and that is mapped to port 4 already, then that would just go from A to D directly. There would be no need for the switch to send it out any other ports. This way we can have what is called micro segmentation, so that each individual device, and that's the idea, has its own switch port and is therefore available to have full throughput on a full duplex interface. Questions about how switches work?
Could you repeat the word micro?
Micro segmentation.
Micro segmentation.
Yep, micro segmentation is when every single device has its own switch port.
In other words, the switch port knows the MAC address when it gets there, and if it's not that one,
right? Go ahead, Steve.
I'm assuming it would reject it.
Well, here's what's going to happen. If it comes in and the MAC address is not in the table, okay, so it has not learned it, does not know about it. By default, it floods it out every port except the one it came in on. Now, let's say it still doesn't, there's no response. At that point, there's actually where there's a little bit of a problem, and that is that you can actually flood the MAC address table. And what happens is it's actually called a MAC address table attack. And so you can take, as a hacker, you can say that your machine has 4,000 MAC addresses, and those 4,000 MAC addresses will fill up the CAM table, the content addressable memory table on a switch. Well, if that table becomes full, the switch starts acting like a hub, and so it will send it out every port regardless, even if it's, you know, it's not supposed to. But typically what happens is if it's not found at all, it would just be rejected at the upper layers. It would say, hey, couldn't find this, and there would be no communication take place. So the switch really only looks to see if it knows the MAC address, and if it does, it will forward it to the table. If it doesn't know it, it will forward it out all ports and try to send it. If that sending fails, layer 3 and 4 and up would be responsible for trying to resend and figure out what's going wrong.
Right. Exactly.
So does that make sense?
Absolutely. The switches themselves, though, are now much more complex than simply
Yes.
data link layer, because I think some of them go 4 layers.
Oh yeah, yeah. The switch, this is a layer 2 switch. So this is a switch that only has layer 2 capabilities. We have the ability to actually use switches that are layer 3 switches. In fact, I may be able to do this. Let me see if I can make this happen. See if I can remote desktop into my, hold on one second, y'all. I'll show you if I can make this work. It'd be really cool. And I'm sure you've seen this already in the CCNA, but it is cool to show it. See if I can get this to pop over. We'll let that keep trying while it's doing that. Oh, there it goes. Okay. So we're jumping in here. I'm RDPing into my desktop at work through our VPNs. Let me minimize this, minimize my PowerPoint I'm doing tomorrow for our NCCIA, if any of you are coming to the conference tomorrow. I hope some of you are able to come tomorrow.
The conference is where?
It is online. It is an online conference.
Did we get a link for
What
that?
is,
It was,
is
I
the
sent it out
time?
several months ago.
Oh, I wasn't a part of your program yet.
Yeah, you probably didn't get it then. Sorry. I actually sponsored 100 free reservations to go to the conference.
But it's being held online.
Yeah, it's in CCI conference. It's a really good little conference.
what is the time?
My
conference?
thing on Wednesday is from 3 to 3:45, I believe. That's my.
So if you don't mind, do I have to register or I can join?
No, you have to register. You have to be part of the conference. If you're missing it, that's fine, because remember, you should have been getting my April is ASC month.
Mhm.
And I'll be going over basically the same things there too. So.
Okay. Okay.
So, but what I've got going on here, folks, is I am, close this. I gotta minimize that. Share my screen again. But what I've done is I've pulled up CML, this Cisco Modeling Labs. This is my personal edition that I've got. And so I'm booting up a switch in iOS. It says a L2 switch, but these switches actually do support layer 3. So what I'm going to do is I'm actually going to create a layer 3 link between this switch and this iOS router here. And while I'm in here, I will go ahead and, oops, wrong thing. I'm going to go back to add a node. I'm going to stick in a desktop node. Let's just put in 2 desktop nodes and get them booted up and going here. The good thing I like about this, again, we're working with real gear. We're not working with simulated gear. I'm gonna actually stop my video because my internet at home is so slow. So it still may not work across this. We'll just have to let it see. But when it does get booted up, I'll come back to it and see if we can't show you a no switch port and turn it into a routable port. But you are very correct, Steve, in that our current switches today, these are layer 2 switches, but we have much more advanced switches today. They can do inter-VLAN routing, and not just inter-VLAN routing, they have the ability to use switch virtual interfaces to route between the SVIs and then actually route up to a particular host. And that's these multi-layer switches, and that's the different look you have here. Even our 2960s have the ability in most cases to become layer 3 switches in a very limited format. So we can take them and create these switch virtual interfaces and actually route between the devices. You just have to turn on IP routing. So, and it looks like my PC is not going to allow me to
And you got all those logical ports too for a single physical port.
Yep.
And then the subnets that are built off of each logical port.
Definitely. So you can create all your VLANs. And in fact, I would say that most of our switches today, especially at the distribution layer, and how many of you are familiar with the 3 layers of the typical 3 layers of network design. There's the core, you got the distribution, and then you got the access layer. And then the access layer is where we, our individual devices connect. So in this picture here, it would be these PCs are connecting to this access layer switch, which are then connected to these distribution layer switches, which will then connect to a core. And those cores, each particular layers in the 3-layer model has a particular function. Core's main function is high-speed redundancy, core connectivity to different parts of your enterprise campus network, like your server block, your remote access block, your data center block, those types of things. Distribution is where you typically do your inter-VLAN routing and where you have your policies. And then the access layer is where your devices actually get onto your network. But these 3 layers are the common items that have been used for 3-layer network design for some time. Cisco now has an enterprise network design that they talk more about, which uses a little different design than that. And this is just not, it is just completely locked up. So it's not going to work. So we'll just disconnect that and be done with it. So, oh well, it was worth a try.
What
My
about
internet's
the,
so slow at home that I have to deal with it sometimes. It's worth it to have cows for neighbors. Wired versus wireless. Now, one of the things I love telling my students is there's really no such thing as a true wireless network. You think about even our cell phones, you hit a tower that's wired somewhere. I also tell folks that my house has 3,500 feet of Cat 5e cable. When I built my house, that was the cable that was available. It also has 1,500 feet of RG6. In other words, if I can put a cable and connect it with a cable, I'm going to connect it with a cable because it's faster and it's more secure. But it's definitely faster. But today's network, wireless networks, we are getting closer to the actual speeds of our wired capabilities. But this goes over the difference in as far as the frame, how the frame is using CSMA-CA, collision avoidance, instead of collision detection, which basically is it listens. If the link is available, it signals its intent to signal. So it sends a ready to send, does a clear to send from the AP, and then the wireless client transmits. So it basically asks to send before it sends. That overhead obviously slows things down. This particular section talks about discovering a wireless AP, authenticating and associating SSIDs. We all have been taught not to broadcast our SSIDs, but due to the very standards of SSID, the second a client asks for the SSID, even if you are telling it not to respond, by standard, it's supposed to respond with the SSID. So not broadcasting or beaconing your SID is a very, very, very limited form of security. Right. I tell you what's funny. Looking at this little router here. I cleaned up a closet. I had top of a closet. I found 5 or 6 wireless home Soho routers that I had thrown up in the closet. And I guess I just kept changing out routers till I finally found one I liked. And now I actually just use the router that come from my service provider with an Orbi. I use an Orbi system. I have an Orbi on the first floor and Orbi on the second floor. I've now put in 2 or 3 of the Google mesh systems. And so quite honestly, that's probably what I would use if I was to put in any more wireless here in the house, if I had to replace my Orbi system. But before that, the Orbi was extremely good. What are y'all using for your wireless?
I have it's both the wireless router and the cable modem in one device.
Yep. Okay.
And it's a fiber connection.
Okay. Well, you're one of the lucky ones that have fiber then.
Yeah, and it has substantial throughput, but again, you're The fastest. Well, your network is only as fast as the slowest link, going back to your comment about the limitations of wireless versus using a cable in your own house for faster speeds.
Do you have gigabit Ethernet to your house for your incoming connection?
Yeah.
Yeah, that's really nice. And we are a long ways from that. I'm on the Starlink waiting list and have been, I guess, for a year, like everyone else. But yeah, we have all learned very quickly that one of the most important things in as far as a basic service that we need is high-speed internet, especially during COVID. Yeah,
Absolutely.
it has been unbelievable how hard it has been working from home. And just like that, if I couldn't show you the example from my office, even though I should have been able to. If I had decent internet, I would be able to. And rural counties are really learning that the ability to hand out and to give high-speed internet. And the crazy thing is, I would pay for it if they would just bring it here, but they just don't have it where I'm sitting. And I mean, I joke and say I have, cows for neighbors, but I live 9 minutes from or 8 minutes from work. So the city limits is less than 4 minutes or 5 minutes from my house. Now, granted, it's a small city, but still, you would think I would be able to actually be able to have that. All right, let's talk a little bit about network topologies, looking at diagrams, physical diagrams versus logical diagrams. This is, again, the physical is how it is connected to devices, whereas logical is how the addressing and the networks are put together on inside of the physical layout. We have all different types of networks, again, SOHO up to worldwide networks. We have LANs and WANs, so local area networks. I teach students those are in a limited geographical area versus WANs. And then all the way down here, here's that 3-layer design again I was talking about, the core distribution access layer. Now you'll also hear many times about what they call a collapsed core design, and that is where the core and distribution layers are combined with one another. You'll see technologies in the core and sometimes in the distribution layer, such as port aggregation through ether channel. They're showing ether channel here on the core layer, but sometimes you'll see that same type of aggregation of links between the distribution layer and the access layer. But the idea being that each one of these layers has a very specific function. There's the collapsed core again, where you've got the distribution and core together, which is common with smaller networks. They have a little video on this, and there used to be an entire certification that was based around network design, the old Cisco Certified Design Associate, CCDA, which I had for some time, but I didn't keep it. Well, obviously it's no longer in existence, but I didn't keep it up once they did away with it. So firewalls, we typically want a firewall or two in our designs. Sometimes many places have a single firewall which exists between the public untrusted and the private trusted networks. These also many times have what's called a DMZ. Almost always have a DMZ, and that is where any public facing thing like your website, your email head-in, any type of services, remote access servers that you need to be able to access to do VPN, those devices exist in the DMZ so that you can go from the outside to the DMZ, but the DMZ is not trusted by the inside. So typically if you're doing an ASA or Cisco Adaptive Security Appliance, the outside will have a security level of 0, which means it's untrusted. The inside will have a security level of 100, which means perfectly trusted. In the DMZ, you'll give it something like a 50, which means it's trusted more than the outside, and you're allowed to go from higher security levels to lower security levels, but not the other way. So the inside at 100 could go to the DMZ, but by default, the DMZ cannot initiate connection to the inside. And that's very common if you've worked with ASAs, or if you work with ASAs or other firewalls, such as Palo Alto firewalls or Fortinet or any of the other firewall vendors that are out there. The big thing about firewalls is today with our firewall devices, many of them are what are called next generation firewalls. So for many years, we had firewalls that were just packet filtering firewalls. So it was really just a list of access control list, permit and deny statements based upon what we set up. Now we have firewalls that can do everything from source destination IP address all the way to, they even have the ability now for next generation firewalls to look at SSL traffic. So if you're connected to a site such as this, I'm connected with SSL, connection is secure, okay? Technically, the firewall can't read what's inside of that. So I could be sending nefarious traffic through that. Some next generation firewalls, and I know Palo Alto has this ability, and I'm sure Cisco's do too, but they have the ability for you to become an SSL in the middle. And so you set the firewall up to where the SSL gets set up between the firewall and the outgoing devices and the firewall and incoming devices, and it can actually read what's in the SSL. Now, that in many ways violates the idea of SSL, but it does let you look into SSL traffic and see what's in it so that you ensure that, for instance, your trade secrets aren't being exfiltrated via an SSL connection. So packet filtering, stateless, you can see all they do pretty much is source IP, destination IP, protocol, source port, layer 3 and layer 4. Stateful firewalls, look at 3 through 5, and then we get all the way up to application firewalls, which can do looking at 3 through 5 and 7, and then next generation, they have the ability to do all kind of crazy stuff. They can look at the traffic going in and out, compare it against threats. They can look at traffic coming in and out and help you decide whether or not sites are on blacklists, just all types of things that are available with the next generation firewalls. One of the things that we have looked a little bit at starting to teach is Fortinet. I don't know how many of you are familiar with Fortinet, but Fortinet has made a real big inroad into the markets for government and small business. We do teach Palo Alto, and their product is an awesome product. And we used to teach the ASAs when we were teaching the old CCNA security class. There is still a series of labs for the CCNA, or not CCNA, but for the ASA. You can get those from either the old CCNA security curriculum, or they have some of those with the network security class that's inside of NetAcad now, which we don't teach because they don't require it to have an instructor training class anymore. So we don't teach that. Here, you just want to stress with your students the difference between intrusion detection and intrusion prevention. So the ability to actually act. So the IPS acts, whereas the IDS typically does not act. It just lets you know about an attack or something going on the network. Whereas an IPS can be configured to start dropping packets. It can be configured to shunt machines into remediation VLANs. So that would be a VLAN where, say, a machine comes online and the IPS sees that it has a virus on it. It would then put it into a VLAN that is separate from all other VLANs until someone on the security team can see what's going on with it. What are some of the disadvantages of an IPS? Can anybody think of a disadvantage?
Well, you have the intrusion detection and prevention system, so you get the best of both worlds. You do. Now, one of the things to think about then is anytime you add a device to your network that's having to break traffic down and look at it, what does it introduce to your network? Overhead and delay, exactly. So one of the negatives would be more overhead, more delay. The other negative too is, what about false positives? You can get a host that gets shunted into it's the likelihood of false positives just based on the law of averages.
Yep, definitely. So you have to tune those systems to make sure they're able to handle and not have false positives. All right. So again, some of the advantages. Technically, an IDS should have very little impact on network latency and jitter, whereas the IPS will have some pretty good, effect. Disadvantage of an IDS, though, is it can't stop anything. So it's just going to let you know about it, and it may be too late already by the time the IDS lets you know. Whereas the IPS can actually stop attacks. But the negative there is it may look at something and think it's an attack when it's not really an attack, and starts dropping good traffic or blocking good traffic. Host-based IPSs that's installed in individual systems. Again, you got to think about it more and more when you add a host-based IPS. That's great. Oh, well, I'm gonna have a network IPS and a host-based IPS, but now you've introduced double the overhead on your network. Not only is the network traffic going to have overhead, but now the individual host is using part of its processor and memory to run a host-based IPS. So it can be, it can be detrimental. But again, like many times, it's worth it for the safety it provides for your systems. One of the important things about these specialized security appliances, you do need to know for the exam what these are. So you need to know that the Cisco Advanced Malware Protection is a box you can put onto your network, which will look for and block certain file types and exploits looking for malware. The WSA is a web security appliance. So its job is to look at the websites that your organization is going to, or your traffic is going to, stopping them from going to known bad sites, looking at sites and seeing if they are trying to in some way compromise your hosts as they're going out to different sites. And so that web security appliance is designed to look at all your web traffic going out and in and secure it. Then the email security appliance is designed to look at your email. So it can do spam blocking, it can do malware protection with AMP. In other words, WSA and ESA can work in concert with AMP to provide protection from malware. So these all work together. So in a perfect world with Cisco, you would be running AMP, WSA, and ESA, and you're probably running their DNA center and everything else. And all of that would be working to proactively keep your network safe from attacks. What are a couple of services that we have? Well, one are access control lists. We're all familiar with those. Series of permit and deny statements. They are very simple though. One of the things we use for ACLs for is access to the VTY lines, a very simple ACL to stop that. But ACLs are pretty basic security, let's be honest, okay? SNMP, Simple Network Management Protocol, you have to really be careful with it because honestly, you can introduce more problems with security by using a poor version of SNMP than using the newest version. But SNMP is ability for you to run network management, and it underlines many of the network management systems out there. Netflow is a Cisco iOS technology that lets you look at flows, which are pretty much source destination IPs, protocol, a flow, a TCP flow, so source destination IP, source port, destination port, layer 3 protocol. But these flows can be tracked so that you can see what devices are going where, what they're accessing, and it can be used for you to be able to identify what traffic is using up most of your bandwidth. That can then be used to make decisions about quality of service for your network and about what traffic needs to be given priority, what traffic needs to be limited, those types of things for your network. This is what I talked about earlier with ports spanning and the fact that normally switches, if there's a packet going from this PC on the left to the bottom PC, the packet analyzer would typically not see it because the switch learns the MAC addresses of the devices on its ports and would only send it from the top PC to the bottom PC. For a packet analyzer to see that, we've got to have a way for a copy of the traffic going between these two devices to be sent to the packet analyzer. We do that with what's called a span port or a port mirroring. We mirror a port and that goes to the packet analyzer. I think you all know what a syslog server is. You know what NTP is. So that's not really a big thing there. I will tell you that one of the things to remember is that stratum 0 is the top level of the NTP. And then down from there, authoritative source, that is stratum 0. And then below that, stratum 1's connected directly to it, and then on down. So maximum is 15 stratums. So 16 would be the lowest stratums level, and that's basically unsynchronized, so it would not be connected to the time server. AAA, big thing here you want to remember is authentication, authorization, and accounting. So first, who are you? Authentication. What are you allowed to do? Can you run that command? Are you allowed in that area? And then accounting, did you run the command, and did you go in the, or like, did you go in the area? So to give you, let's think of this in terms of a building. Authentication, you have to show your card to be able to go in the building. Once in the building, your card allows you to go in certain rooms. If you go in certain rooms, there's a system in place showing everywhere you went in the building. So we basically have this on our campus. We have a card-based system that if the campus is closed and we go on campus and use our card to get in a building, it's going to show where we went, what building we went into. Now, it doesn't show every single room, but it would show that we went into the building. For devices, there are two different types of protocols used for AAA. One is TACUS Plus, which is a mostly Cisco supported standard. It's actually become a little more open lately, but it is mostly Cisco Plus. Cisco was Cisco proprietary in the beginning, and then Radius. And so TACUS Plus is transport layers TCP, very important. Just remember that by knowing that when you could get a question on that on the exam, that TACUS Plus uses TACUS and Radius. What is one of their main differences? TACUS uses TCP. Remember that by beginning with a T. Radius uses UDP. Remember that because of the U in radius. Okay. TACUS is bidirectional challenge. Radius is unidirectional. Confidentiality, entire packet is encrypted with TACUS, whereas in Radius, only the password is encrypted. All right. One of the big difference between TACUS and Radius is the accounting abilities, and that TACUS has very limited accounting abilities, whereas Radius has very extensive accounting abilities. It was for that reason that Radius was used back in the old days when we used dial-in internet, because it had the ability to keep up with exactly how long you were on, what you did, and therefore you could be charged for it. So we'll talk more about these as we get into TACUS and Radius servers down the road here. And then VPNs, this is using a private network and creating a public network and creating a private tunnel between different sites. And now one of the things to remember here is there's two different types of VPNs. There are remote access VPNs and site-to-site VPNs. And the main difference between these two is where the endpoints are. In a remote access, the endpoint is a device, such as a laptop. So normally we have to put, we normally load software, load some type of VPN software on the device. Okay. So great example I just had there was when I went down here and clicked and opened up Global Protect and click connect, that would connect me to my remote VPN at Stanley. I have software loaded on this local machine. A site-to-site VPN is the endpoint as a network device. And really the clients have no clue that there's anything going on, that they're even going through a VPN tunnel. So the people in this branch office, there'd be a router here connected, router or firewall, one of the two, or a VPN device. They're actually VPN appliances going back to the central site, and the hosts in this branch office may not even know they're going through a VPN to get back to the central site. The SOHO could be designed, could be set up different ways too. This could be a site-to-site VPN, or it could be a remote access, just depending on how it's set up. The other thing that's normal is remote access VPNs are used when you don't control the endpoint, control the location of the endpoint. So, you know, if you're traveling, if you're going from hotel to hotel, you know, you'd use a remote access VPN. If you control the endpoint, then you can put in a static or a device with a static IP, although a static IP is not required for a site-to-site VPN. You now can do it with dynamic IP addresses too. In fact, you can have dynamic DM VPNs, dynamic multi-point VPNs all everywhere, but that's not part of this class. But typically with site-to-site, we do control the location and know exactly where the devices are going to be. Questions about VPNs, remote access VPNs or site-to-site VPNs, those two concepts. Go ahead. No questions? Okay. I just want to talk a little bit about those. And folks, that's it. Now we're really down to our next set of items will be looking at attackers and their tools and getting into common threats and finally getting into more of just the security items that are part of this class. Any questions, anything you want me to go over while I'm sitting here in this particular content?
I was going to go back all the way to your almost your very first question.
Okay.
Which was if we had any problems with the simulator. And I believe I did with regard to being able to use the traceroute command from the Linux CLI.
Okay, we're using NetLabs or using locally loaded machines?
No, I was using NetLabs.
Okay, let me ask you this. Did you use, one of the key items you have to do is, did you use the, somebody's doing BGP. You remember what lab it was?
No, it was the basics of networking. Okay. Showing the command line interface, you could trace a route.
Okay. It may be that
it was in NetLabs though.
I'm sorry, go ahead.
It was in NetLabs.
Okay. Make sure when you're in NetLabs that you're using the documents in NetLabs. Okay. If you're in here, like for instance, let's say I'm doing, let me go find a lab here. Go find course index labs. Okay, so here's labs. Let's go down and look at some in this chapter we're in.
It was 5.1.
5.1. Okay. Okay. So right here, tracing a route. Yeah. Okay. Yeah. 5.1.5. So let's go over here. Tracing a route. When you do this lab, when you go in here and schedule yourself a pod.
Yeah, I did that.
Okay. What you've got to do is you've got to make sure, let's let this boot just a second. You cannot use the documents from here. If you use this document, it probably will not work correctly. All right. You must use the documents inside the lab itself. So this content tab, I had to get booted up. And I'll actually show you, you can probably be able to see a pretty dramatic difference between these two labs.
Well, I thought we had to upload download that. We thought we downloaded that, converted it from PDF to Word, and then uploaded that. And you're saying that's not what we use?
You got to use the one that's inside of the pod, not the one inside of the course. See, yeah. let me get in here. Let this load. It's for some reason it's taking.
Sure.
But you've got to use the content in here. See how this one says modified for NetDev group?
I think you did mention that at the beginning of the course.
Yes.
And I forgot about it. So in other words, this one also can be downloaded and converted and then uploaded again.
Correct. Yes. Yes.
Okay.
See,
it's the one.
See how different.
Once you're in NetLab, that's the one.
Correct. Yes.
Sorry, that's what I did wrong.
That's no problem. You'll look how different these are. See, these are extremely different. The commands are very different because what they did is they actually gave you a traceroute file that will let you look at that file and use it as one of the possible ways to do it. So yeah, they are very different. If you don't use the one that's inside, then it won't work. So just make sure you always use the one that says it's been updated for NetLab Plus. But I guarantee you that's what the issue was.
Yep. Thanks.
No problem. And like I said, you can just download these and then you can
Convert them.
just like the other one. So it's not a problem. All right. Any other questions? I'm going to end this reservation so I'm not using this pod in case somebody would need it. All right, everyone. Well, that's all I have for today. Thank you so much for coming. I appreciate it. Everyone be safe. If you need anything from me, please let me know.